What's up, guys? Welcome to MVP Java. I'm Andy, and today we're going to be taking a look at nested transactions in Spring using Spring Boot 2.x. Okay, actually Spring Boot 2.1.6, but you know. So first things first, we're going to be talking about nested transactions via annotations. Okay, so if you go to my blog post over here in which I wrote about nested transactions, I start off the discussion on what the available propagation levels are. All right, now there's 6 that are usually used. The one that's used most likely about 70% of the time is the required, which always starts a transaction 100% of the time. And so you wouldn't have to put it in the propagation level in the annotation because it's the default. The rest you do. Now, these are actually used as well if you're doing Enterprise Java and Java EE, and they're part of that spec in the JTA. However, there's one that's kind of cast aside here, a 7th one called nested, which is what we're going to look at in this tutorial. Now, the reason why it's usually cast aside is because it's not actually portable across all transaction managers. Actually, for Spring, it is only really supported out of the box with JDBC. Okay, so actually let's take a look at that in the pom.xml file, what the requirements are for this tutorial. So like I said, we're dealing with Spring Boot 2.1.6. I'm using Java 8. And here you'll see that I'm using the Spring Starter for JDBC. There is no ORM, GPA implementation, or anything like that. And the reason for that is because out of the box, I'm only going to be using a DataSourceTransactionManager, which supports nested transactions. We're going to be using an embedded H2 database over here. So we're going to want to take a look at the web console. And that is why I need the web starter, because this application is not per se a web application. And then in order to simplify the tutorial, I opted to use Google Guava to partition a list that we're going to be uploading or inserting into the database, just so we have less lines of code to look at in the tutorial. Okay. Now the use case that I'm going to cover in this tutorial actually has to do with something that I came across in my career. I used to work for actually the Canadian Space Agency, almost for 10 years, and this is actually me over here. With the hairnet, looking sharp, back in 2005 with the SciSat-1 spacecraft. And what we had to do on a daily basis in operations was upload a list of timed commands to the spacecraft database, right? That had, let's say, a command name, right? To say, hey, do this, and at a time. So we could say something like, at UTC time 12:00:00 with the seconds and everything like that, go all out and specify everything. Turn on this piece of equipment, or turn off, or go in this kind of mode. So we had really hundreds of commands every day to upload. And this is the use case that I'm going to use in this tutorial. Okay, I'm going to mimic that, uploading to the spacecraft database. So let's take a look at that. You can see here the implementation of one of the interfaces is going to be called Satellite Uploader Service. All right, we'll get back to that in a second. So this is actually a pretty cool example. Let me kind of walk you through very quickly the main application, and then we're going to take a look at really what a nested transaction is and how we can use it to satisfy this use case over here. So again, we're using a Spring Boot application. And I'm implementing the command line runner, which means that the run method is going to get invoked here. And I've uploaded, or I've auto-wired, an uploader service interface here. This is an interface that we're going to take a look at. And it executes an upload method. And what we're going to upload is a list of timed commands. So we're actually going to build, let me actually annotate this screen over here. I'm actually using a utool, so bear with me, please. So I'm going to build this list of commands over here. Now you see I've separated, this list of commands with spaces over here, and there's actually a reason for that, and I'm going to go through that reason right now. Okay, so these are a list of timed commands. You can see here that this is like a string right now to tell the spacecraft, turn star tracker your mode to reboot, so that would reboot that unit at this time. Okay, so we just have 10 in total list of timed commands to upload to the spacecraft. Nothing special there. What's going to be special is that we're going to actually, in the upload method, want to start a new transaction 100% of the time. So in essence, when we call the upload method, it's going to start over here, and we're going to start a new transaction. Okay, now the important thing to remember here that this is a top level transaction. Okay, and at the end we're going to want to commit to that transaction. So far everything is as expected. However, what's going to be different is this: we want to have what's called a best effort approach in this use case. Best effort approach. Why am I saying that? Well, I don't even know if I'm spelling approach right anymore. I don't spell much anymore. But what happens is these 10 commands in a use case such as this, as uploading into a spacecraft, or it could be a bad connection that you have to your database, is sometimes these 10 commands. Now, again, I'm using 10 here so we can make the example manageable, but you know, these could be hundreds of commands or thousands of commands, whatever your use case is. Let's say there's a problem on the 10th one. What we don't want is the whole thing to roll back, because if that happens, it's kind of a waste of time and resources, because you really want to have, like I said, a best effort approach. What you want to have happen is say, well, maybe the 10th one, there was an issue with it, right? But we actually want the 9 to make it, right? So we actually want to commit those 9 commands, and we would actually, in this case here, we would log it and retry at a later time, okay? So this could be because you have a bad connection, right? And you never get to the point where you can actually upload all these 10 commands because the connection is so bad, you're always gonna have a hit, okay? So that's one reason why you would want to use a use case like this, which is exactly what was happening in the use case that I came across. Is a lot of times when you're uplinking with the satellite, you have low elevation passes and your RF is hitting buildings and you're getting bit hits. And so what happens is you get drops, okay? So we want to have a best effort approach when dealing with this. So what are we going to do about it? Okay, so for what we're going to do here is we're going to partition this list into different chunks, right? So we're going to say this list of 10, we're going to want to break it up into partitions of 3. Now obviously the last one can't fit into 3, so it goes into 1. And we're going to create nested transactions. So I'm just going to say NT for nested transactions. This will be nested transaction 1, nested transaction 2, and so on and so forth. Again, with a bigger data set, it would be a little bit different, right? Chunks of 10 or chunks of 100 or 1,000, whatever. Now what's going to happen is that when the top level transaction gets called, it's then going to start what's called a nested transaction afterwards. And that's going to create what we're going to see in the logs after, called a save point. And that save point is a safe place to go back to if anything goes wrong in that sub nested transaction. So for example, let's say this one here, there's a problem. What's going to happen is it's going to roll back, not the transaction, okay? It's going to roll back to the save point. Now that's super important for you guys to remember, right? Nested transactions are not separate, isolated transactions from the top level transaction. That's not what a nested transaction is. A nested transaction actually just saves a save point and rolls back to that save point as if nothing had ever happened if we have a runtime exception. Now, let's even actually give another example. Let's say that again, this guy, there's a problem with it, okay? And we go back to our save point. Now, at that point, you will notice that nothing gets committed or anything like that, right? So what happens is that the transaction actually keeps going on to the next one. That's the best effort approach. Now, let's say something doesn't go wrong. Everything goes right. Let's say this guy over here, beautiful, right? Successful. That does not commit the transaction, the nested transaction. There is no commit in the nested transaction. The commit of this successful operation over here will only happen at the end of the top level transaction. So that is an important distinction for you guys to remember about nested transactions, which is different than, let's say, if you were using the propagation level requires new, okay? So again here, let me refer back to the article here and the other propagation levels. A lot of people confuse nested with this guy over here. This guy over here creates a new transaction. It's isolated. If something goes wrong in it, it does commit or roll back that transaction apart, separate from the top level transaction. Not the case like I just described for nested, okay? So now you guys are well versed in nested, and now we're gonna see how it actually works in code. So let's go take a look at the uploader service and how it is that it can actually start a transaction 100% of the time. In our upload service interface, you'll notice over here that I have the @transactional annotation, okay? So this says that every public method in this class, and there's only one right now, will 100% of the time be run in a transaction because the propagation level by default is required, okay? So anything that implements this interface will have that method executed in a transaction. Now, can you put this annotation on the class instead of in the interface? Yes, you can. However, this is not only a preference, but considered a best practice as well. So let me go now to the actual implementation class called Satellite Uploader Service. And you'll see that this is a service class, okay? And that usually it is a best practice to start your transactions at the service layer. That's where your transactional business cases should be, right? Top level all the way to the commit. So in this case here, upload is already an @transactional service method. Why? Because I just explained that you're implementing that interface, so all the public methods in it are transactional. Okay, so now let's actually take a look at the details of the whole operation. You'll notice here that I'm using Google Guava to partition the list of commands that's coming in. There's 10 coming in. I'm partitioning them in a desired partition of 3 pieces each. Now that goes back to the slide before where I showed you that we had 4 partitions, 3, 3, 3, and 1, okay? Then I'm gonna loop through each partition, use the Google Guava API here to actually transform this list of strings, or a list of strings, to an array of strings here, okay? And that's because the uplink method of the DAO actually requires that. So where's this DAO coming from? It's actually coming from the constructor, and it's being auto-wired into the constructor by Spring. Now again, just a little side note here, Spring will actually automatically put this annotation in there for you if it's the only constructor. But I like to put it in there. I find, for me anyways, it's a best practice. And since I'm using annotations elsewhere in the code, I find that it's a good form of documentation. Okay. Now, you'll notice at the bottom here, I have a try catch. And I mostly have it for demonstration purposes, but obviously in operation, your operational code, you'll want to do this as well. And if anything ever goes wrong, I just want to say, hey, the transaction will commit regardless in failure of nested transactions. So this uplink method here is actually going to start our nested transactions, and we're going to see how that is actually happening right now. Okay, so let's go to that DAO right over here. And that DAO is actually quite simple, all right? And let's walk through that DAO right now. So I'm using a template, a JDBC template that I'm auto-wiring into the constructor, okay? And I'm gonna be reusing that in the uplink method. Now notice here This is our nested transaction propagation level, right? So every time we come in here, we're going to create a save point, right? Now, who's actually doing this? This is going to be the DataSourceTransactionManager that's going to do this, right? This is, again, from JDBC, the JDBC starter that we have in the pom.xml file. So we're going to upload this as a batch. So the first time we're going to invoke this is going to be 3, and then there's going to be another 3, and another 3, and then 1, right? So that's going to be our 10 in total timed commands. So if everything goes good, we get all of them in the database. If something goes wrong, which is actually what I'm doing here, I'm actually going to introduce a random exception based on an application property value, okay? So this demo failure mode gets set in this setter by using a property that we're going to take a look at right now in application.properties. That's the file that's going to have all those Spring properties, and as well, in this case, my application properties. Okay, so let's go take a look just as a sidebar here. There it is. What this is saying is false. For this run, don't throw any random exceptions. So I want to show you the log file, the console log, because I'm going to put this debug to trace so we can see everything. Then when I want you to see what happens when things go wrong, I'm going to set this to true, and that'll throw a random exception. The rest of these properties are actually used for the data source in the H2 console, okay? You can see here that I created a satellite test database that we're going to use in the web console. And being a Spring Boot application, if I have this file under source main properties, or source main resources, excuse me, it's going to execute this DLL for me and create that table with the command as a column and the time of execution for the timestamp. Now I commented this out because I wanted to do a little test to insert some data before, but you can include that in another file called data.sql. But that kind of defeats the purpose of the tutorial, doesn't it? Because we want to actually see this done in nested transactions. So let's close that. Again, everything is available on GitHub, guys. You just go over there, and on my GitHub, you'll see all my repositories, and there you go, Spring Nested Transaction tutorial. That was just done last week because I did the tutorial first, the blog post, and you just go in there and it's all there, okay? All right, so let's go back to the DAO, which has the nested transaction code. There's really nothing left to say here. The only thing I will briefly mention is that we have here the method that throws the random exception. So it's going to really generate a random number from 0 to 2. And if that is equal to 1, then we're going to throw a runtime exception. And in that runtime exception will cause the nested transaction to roll back to the save point as if nothing happened. Again, the top level transaction is not rolled back. It will be allowed to continue to the next nested transaction if there is one left to partition the list, okay? So very important for us to know that. Let's actually run this application now. Enough of me talking. Let's say, well, let me just go to the main. Not that we have to go to main to do this, but Spring Boot app, open this up, and take a look at what's actually going on. Okay, now I purposely paused the application at the end, okay, so we can actually go to the URL in the console and check what happened. So in this case, let's just annotate the log to give you kind of like an inkling on what's going on here. So first off, you can see that this is the data source transaction manager. Again, we're dealing with JDBC that supports nested transactions out of the box, and it's creating a new transaction. And this is the top level transaction. Okay. And at the end, we're going to see that it's actually going to commit the transaction. Okay, over here. So this is, let's say, the commit. There's the commit. So this would be the end/commit. of the transaction. So from here to here, we have our top level transaction. Now, inside there, we're going to be creating nested transactions. Okay, so there's 1, 2, 3, 4. There should be, right? Because like I said, we're breaking up the list into 3, 3, 3, and then there's 1 over here. So this is nested transaction 1, nested transaction 2, and so on and so forth, like our example was explained to us on the main method before. You'll notice that they are creating, right, the transaction manager is creating save points and then going back to that save point when everything goes as planned. There's no exceptions, everything goes smoothly, right? So this is kind of the green path, everything goes as planned. So let's, in essence, what should have happened is there should be 10 time commands in the H2 embedded database, and let's go actually check that out right now, okay? So go here. I have this saved here in a tab, H2 console. I've already been playing with this. This is the satellite test. Let's connect to that. Click on the table time commands. We can select all records. And then here you'll see that we actually have all 10 records, and you see their numbers sequentially 1 to 10. Okay, everything is there. Perfect. Now let's go back to the application and actually cause a random runtime exception. Let's close this over here because I paused the application on purpose. We'll go to our application.properties and we'll change this to true. We do want random runtime exceptions to occur in the nested transaction. So let's actually see what could happen. So we'll run this as a Spring Boot application and then just sit back and watch the drama unfold. Now, because this is random, it is possible that there is no runtime exception that gets thrown, which actually is the case right now. I don't see any stack traces, so unfortunately we gotta do the run again, okay? All right, let's do this again. I'm sure the second time, I hope the second time we're gonna get some exceptions over here. Unbelievable. Did I actually change the properties in the properties file? Let me double check here. I might have. Yeah, okay. That's twice that happened. There we go, finally got it. Okay, of course that happens in a demo, right? That'll never happen when I'm actually testing this offline. So, okay, so let's take a look at this again. So over here we have creating a nested transaction. No, let me go back up. Let me go back up because now the stack trace is is kind of throwing things off the screen, right? There we go. I'm gonna have to annotate this twice, it looks like. Not a problem. So where are we starting our new transaction here? Our DataSourceTransactionManager is here. And we have here a new transaction, right? So this again is our top level transaction. Now, let me actually make this a little thicker. It's a little bit thin for me. And at the bottom, it's kind of off the screen now, but we'll go back to it and we'll see our commit later on. Now we have our nested transaction here, over here, and over here. So again, same thing over there. We got nested transaction 1, nested transaction 2, and nested transaction 3, all the way to 4. And everything goes good, right? To a certain degree. We have here our save points that get restored. But over here, we got a problem. Over here on the fourth one, there is a rollback that happens that I induce, again, randomly. But you'll notice it says rolling back to transaction save point. Okay, so we go back to that safe place, a bookmark, if you will, as if nothing happened. But the transaction should still commit, and we should still get 9 out of 10 commands. Let's actually see if that's true. Let's scroll down. Yes, that's the stack trace of the random exception that gets thrown. That's fine. That's expected. You can see here the timed, whoops. It's funny how this thing kind of decides the thickness. I didn't choose that thickness. Okay. And so we got our runtime exception. That's fine. And over here, you'll notice that at the end, the DataSourceTransactionManager, even though that happens, is still going to be committing the JDBC transaction. We still get a commit That didn't roll back top level transaction like I said. All right, so this could have happened on the second partition. It could have happened on the second and third partition. It just happened to happen on the last partition, which is just one time command that didn't make it. So if we go take a look at the H2 database, we should just have 9 timed commands, and the 10th one, right, with ID number 10 should be missing. So let's go check that out. All right, go back to our H2 console. Let me refresh this, reconnect, and do the same steps over again. And you'll notice now that in effect we have a 10th one missing. The ID 10 is missing, and that's normal, right? Because we had that rollback. So best effort approach, we ended up uploading the best we could. But here's the thing, when such a thing happens, I didn't do this in the tutorial because again, I try not to show too much code in the tutorial, but in this case here, what you really want to do is you want to catch the exception, right? You want to catch the exception, log as much information as you want. And the reason for that is you're going to want to actually do something about it, right? You're going to have to log, because afterwards you're going to want to retry at a later time. Now for us, it was, let's say on the next orbit when we had contact with the satellite again, we would re-inject or re-upload those commands that were not able to make it on the previous command, on the previous pass, if that actually had occurred, okay? But here's the thing, you want to also then rethrow it, okay? If you don't rethrow it, what's gonna happen is it's not gonna roll back to the save point, right? So you actually want it to go back to that save point as if nothing ever happened. Now you can log this over here, you can log it on the calling transaction too if you'd like. I'd rather take care of business right where it happens instead of waiting for it to bubble up in the service layer, because there's not that many methods in between the service layer and this method right here, so it makes sense to do it here in my opinion. But don't forget to do that, okay? So that is how you actually work with nested transactions. Actually, just for the fun of it, what I'd like to do is go back here, because I wish that I know it's random and stuff like that, but I wish it wouldn't have failed on the last one to show you exactly what would happen if we had multiple failures. Let's see if we can get multiple failures happening here, right? There we go. Looks like we got one. Okay, but this one happened on one that had 3 statements. Okay, so that's a little bit better. If we go back to the console now and we refresh this, looks like it happened on the 3rd one, right? So we reconnect, and you can see we have 1, 2, 3, and 4, 5, and 6 are missing, right? So 4, 5, and 6 are missing, which means is the second partition that actually had the problem. So if we actually go up here, we can actually, again, 1, that's the first partition. 2, okay, that's where the exception happened, so that makes sense. 4, 5, and 6 didn't make it up, and then the 3rd partition made it up just fine, and then the 4th one as well, and then we have our commit again, okay? Our commit is just a little bit about transaction commit. So now you guys understand the flow, and if you actually want access to these logs and actually see this in action, you can go to the blog and actually not only include snapshots of the code in the explanation, but I have annotated logs over here. You can actually see the magnification, and we can actually download these logs and just kind of keep them for explanation's sake. Okay, so there you guys have it. Don't forget to get the code off GitHub. Also, don't forget to sign up for my Facebook account where I put a lot of sweet pictures of myself, right? So you can make fun of. Actually, don't make fun of me, please. And then you have my obviously my YouTube account. Please try to subscribe if you can. It's free. Also, give me a thumbs up if you like the video. Share anything to encourage me to keep on doing this. Obviously, this takes a lot of time and effort, but if I hear back from you, if I get comments, if I see that there's some appreciation there, that keeps me going. So thanks a lot for everything, guys. Hope you appreciated that. And until next time, I'll be getting the next one ready. Ciao.